2. So excited to continue on teaching chemistry and learning together with you. This week we're going to learn about atoms, and that's what this first video is about. If you remember last week, it was your third video. We talked about elements, and we learned that elements are the purest substances on Earth, and that you can't take apart elements into anything else. And there are 92 naturally occurring elements in our world, in our biosphere, and then there are 26 other man-made elements. And so we know that all of matter is made up of these elements. But how small can we get in that pure substance? Well, today we're going to talk about that. If you pretend, we're just going to pretend that these things here, these beads, are all examples of some form of a pure element, okay? And so we have, some are a little bit bigger, and of course they have different physical properties, if you remember from last week. But each one is different, and this one, we'll just call this the orange element. How small can we make this element? Well, a pure substance can be quite large, but it can be broken down into the simplest, smallest piece of an element, and that is an atom. So each one of these pure substances can be broken down into its smallest form, which is one single atom of an element. So an example of this would be gold. We talked a little bit about gold last week, and here we have an atom of gold. Remember that the gold element is named after its Latin name, aurum, and so here you have an atom of gold, and it's really, really tiny. An atom of gold measures 0.1441 times 10 to the negative 9 meters, or 0.1441 millionth of a millimeter. Here we have the smallest unit of iron. This is an atom of iron, and the symbol for iron is Fe. So an atom is made up of two regions. As you can see in this picture, the first region is this center area, and that is called the nucleus. This is the center region of the atom, and if you know anything about biology, you may have learned that in biology, the nucleus is the region of a cell that contains all the genetic information that is specific for one organism. Okay, so that's different than in chemistry, and there's no genetic information in the nuclear region of an atom. Instead, the nucleus is made up of two types of particles that's made up of protons and neutrons. Protons were the first subatomic particle to be discovered, and they were discovered in 1886 by German physicist Eugene Goldstein. That's this handsome gentleman right here. The neutrons were discovered in 1932 by English physicist James Chadwick. Sir James Chadwick. So these are the two subatomic particles that give an atom weight. So remember that weight is dependent on the force of gravity. And the proton and the neutron are both located in the nucleus. Neutrons have the same weight as protons and contribute to the overall weight of an atom, and it's one of the physical properties that define the atom. There can be many protons and neutrons in the nucleus of a single atom. So for example, here we have an atom of carbon. Carbon has 6 protons and 6 neutrons. The protons are the red dots in the center in the nucleus here. They're the ones with the plus symbol, okay? Mercury, on the other hand, has 80 protons and 121 neutrons. So it's important to remember here that you can have the same number of neutrons as protons, but you can actually have more neutrons than protons in the atom, in the nucleus of the atom. The second region of an atom is the extranuclear region. This is the outside area, or the area surrounding the nucleus. This extranuclear region has only one type of subatomic particle called the electron. So this is still the atom of mercury, and you can see that outside the yellow circle is the extranuclear region, and it is filled up with many, many electrons. Electrons were first discovered in 1897 by the British scientist J.J. Thomson, but he called them corpuscles. Electrons move very fast, near light speed, in this extranuclear region. The faster, more energetic electrons are further away from the nucleus than the less energetic electrons, and they remain in the inner shells. So we're just going to watch a little video here that will hopefully demonstrate a little bit how the neutrons and protons in the nucleus behave and how the electrons behave outside of the nucleus in the extranuclear region. So here we have Cole riding the tricycle. He is a slow-moving electron, and he is circling the nucleus where Ellie and Tatiana are, and they represent the neutrons and the protons. We'll say that Ellie is the neutrons because there's much more of her. And here comes the fast-moving electron. Whoops, too fast. He can't stay in his shell. Let's try that again. So here we go. Creston, the very excited and energetic electron, is moving in the outer shell of the extranuclear region of the atom. And so the faster moving guys, they stay on the outside, while the slower moving electrons stay closer to the nucleus. They have less energy. Thank you for your help, everybody. So the more energy an electron has, the faster it will move and the further away from the nucleus it can be. The fastest, most energetic electrons will be found in the outer shell of the atom, or if they're in the furthest shell from the nucleus, it's called the valence shell of the atom. So atoms with many electrons may have up to 7 shells with orbiting electrons around the nucleus. And this is an atom of francium. All the subatomic particles, the protons, neutrons, and electrons, are called subatomic particles because they are all parts of an atom. They're part of an atom, so they're even a smaller part than the atom itself. And they are very important because they actually give each atom its identity and its nature, like its appearance and personality, like our appearance and personality. An atom of an element has its own unique set of physical and chemical properties. Over time, there have been different ideas about what an atom might look like. The first model of an atom was proposed by James Dalton in 1803. He held to an ancient Greek idea of what an atom was. The word atom came from the Greek word meaning atomos, and this word means indivisible. They believed that the atom was the smallest unit of matter and was, in fact, indivisible. So it couldn't be divided any further. And we have come so far in that now. So we have a few different models here. The first one was proposed in 1803 by John Dalton. And then in 1904, so 100 years later, the next idea of what an atom looked like was proposed by J.J. Thomson, and it was called the plum pudding model. In 1911, Ernest Rutherford came up with the nuclear model, and he was the guy who really discovered that protons and neutrons exist in a nucleus. He did some experiments, and because of that, they found out that there is a cluster of protons and neutrons in the center, but then there's not a whole lot. The electrons are actually spread out outside of the nucleus. Then, after that, we have the planetary model, which was proposed by Niels Bohr, and in 1926, we have the quantum model, which is the current model that we use today. We're just going to look here again. 1913, Niels Bohr. Yeah, Danish! The Danish scientist Niels Bohr proposed the planetary model of an atom. That's Niels Bohr. So this model is widely used to explain the physical structure of an atom, and it is the model that we will be using ourselves because it is probably the most easy to understand, and it's the simplest way to draw a diagram of an atom. So these are some Bohr models of atoms and how the nucleus looks and how the electrons actually, he came up with the theory of how the electrons actually are positioned in the extranuclear region of an atom. Atoms may have an electrical charge to them, which allows them to join with other atoms to form a compound. So we saw this already last week. This is a molecule of water. And a molecule of water is an example of a compound. A compound is no longer a pure substance. It is made up of more than one element. So in an atom, this is really important to note. In an atom, every proton has a positive charge. The neutrons have no charge at all, so they're completely neutral, which is why they're called neutrons. And electrons have a negative charge, so they have a -1 charge, each one of them. If the number of electrons in an atom is equal to the number of protons, the charges will cancel each other out, and the atom will remain neutral or have 0 charge. And that's it for video number 1.